I'm Anil Kumar, and in this particular video, I'll take 4 different examples and write equation of these sinusoidal functions in the form of f of x equals to a times cosine k x minus p plus q. Well, these figures are kind of distorted, but I'll clearly show them in the following pages when we write their equations. Now let us first understand, given any curve, how to write its equation. The process which I follow is kind of like this. You should first read from the graph maximum value, minimum value, and time period. Now from these figures, you would get all these parameters, beginning with q, which is called as axis. So q is equals to average value. Let me write maximum plus minimum divided by 2. Amplitude A, it should always be a positive value. It is difference of these two, maximum minus minimum, divided by 2. Now to find the value of k, if you are doing it in radians, then one full circle is 2 pi divided by the time period. Let's say time period is t. It is also equals to 360 degrees divided by t if you are doing it in degrees. Phase shift p is kind of critical. You have to read it from the graph. In case you are working with cosine function, we are going to look for maximum value. So for a cosine function, normally it starts from here. Now phase shift really means, when you're looking at the cosine function, from where we get the maximum. Where is the maximum? Closest to the origin. That's the idea. So if you're writing cosine function to find p, you have to locate position of first maximum. Is it okay? Now it is kind of critical. So as we do few examples, it'll be absolutely clear. So I hope this is absolutely clear which we have taken up. So let's take these examples one by one. The very first one is, we call them sinusoidal functions, right? And if we are writing a cosine function, well, all cosine functions are sinusoidal functions, correct? They're only shifted by 90 degrees and it's the same curve. So as I was saying, we have a curve here, sinusoidal curve. Let's read the maximum and minimum value. So in our case, the maximum value is 3. Minimum is -1. And time period t is, for finding time period, you could look into maximum minimum, that is half the wave. Now here it is 0 to 2 pi, so it is half the wave. So we should say twice 2 pi, which means 4 pi, correct? In case you are working in degrees, then you should know that pi is 180 degrees and this is 360 degrees. So in that case, half wave is in 360 degrees. So the time period for those who are doing it in degrees will be 720 degrees, correct? So we can write equation in both degrees and radians. Now let's find out these values. So q is average of these two. So I'll just write 3 plus minus 1 divided by 2. We'll not repeat the formula, which is maximum plus minimum divided by 2. And this value is 3 minus 1 is 2. 2 divided by 2 is 1. the value of A, amplitude, is you have to take away one from the other, that is 3 minus 1 divided by 2, and that gives you 4 divided by 2 as 2. K is, if you're working with radians, it'll be 2 pi by t, which is 4 pi, so it could be written as half. Else K in degrees could be written as 360 degrees by 720, and still you get the same value, half, right? Now phase shift, we have to see maximum. You could say that phase shift is 360 degrees to the right, or we can also note here that it starts with a minimum. So if it starts with a minimum, think as if the graph of cosine has been reflected, right? So we'll consider that to be reflection on x-axis. Do you see that? So we can make A as negative. That means A is equal to, since amplitude for us is 2, instead of 2, we'll take it minus 2, which will take care of reflection. I hope you get an idea, right? So in that case, we can say that the phase shift is half the time period, correct? In a way, this is half the time period. Looking into all this, combining these terms, you can easily write down the equation, right? So we can say f of x is equal to amplitude, we are taking negative for reflection, 2 as the absolute value, cos k is half x, and since we have already included phase shift here by reflection, so there is nothing here, and as far as q is concerned, it is plus 1, correct? So as you can see, the axis goes through 1. So that is how you could write down the equation for this particular sinusoidal function. So let me take the next one now. I'd like you to pause the video, write down the equation, and then look into my suggestions. What we have given here are 2 points A and B. A is the maximum at 112 and B is minimum at 5, 4, right? So these numbers are 5 and 4, and A is maximum at 112, right? So take these numbers and then write down cosine function for the given wave. Now let us try to find the equation. So here we are given 2 coordinate points, A, which is 112, and this is also the maximum. And we are given B, which is 5, 4, which is minimum for the graph. So if you are taking distance between maximum and minimum, that is half the time period. So time period t is difference in x values, which is 5 minus 1, times 2, since it represents half the wave, right? This is half wave. Therefore, time period is being multiplied by 2. Now, once we have these values, it's kind of simpler to find the equation. So let's begin by finding the axis itself. So the x is something which goes through the center of this graph. The value will be midway between the y values, right? So q, the axis, is add y values, which is 12 plus 4 divided by 2. That gives you 16 divided by 2 as 8. So y equals to 8 is the axis for the given curve. Amplitude A is difference of these two divided by 2, which is 8 divided by 2 or 4. Phase shift. Phase shift, you can clearly read the maximum is at 112, so phase shift is 1. Now, once we know all this, okay, k is the last thing to do. If you're working in radians, it'll be 2 pi by the time period, which is, I should calculate this, 5 minus 1 is 4, 4 times 2 is 8, right? So it is 2 pi by 8, which is pi by 4. If you're working in degrees, let me write here, then be 360 degrees divided by the time period 8, right? So, and that will give you 8 times 4 is 32, then 45 degrees, which is same as pi by 4, correct? So you have all the things required to write down the equation. So let's write down the function for the given graph, or equation for the given graph. It is A is 4 for us, cos of, k is pi by 4. Let me write in degrees this time. So I'll write 45 degrees. Okay. Now here, I will not mix it up. We'll actually work in radians. So we'll write pi by 4. I'll explain you later why. So pi by 4 is the k value, x minus 1, and the q value is 8, which is the axis, correct? So that gives us the equation of the given graph. Now, as an added exercise, I like you to write down the equation in the form of f of x equals to a sine k x minus p plus q. Okay, so try to write down an equation in these terms. Here we are given a sine function where the maximum is at pi by 4, or you can say 90 degrees, 45 degrees. The minimum is at minus pi by 4. The maximum value I can read as 1. The minimum value is minus 5. Correct. What is the time period? Well, the time period you can measure from here to here, one full cycle. Between two minimums or two maximums, you can always measure a time period. Correct? So the time period here is, or you could see from here also, if I do the axis, which is kind of easier, from 0 to pi, do you see the time period? It is pi. So let me write down what is given to us. Maximum value in this case is 1. Minimum, what we have here is minus 5. And time period t is pi. So those of you who are doing in degrees could do 180 degrees, correct? Now based on this, we can calculate all these values. So we have q, the axis, as sum of these two, 1 plus minus 5 divided by 2. That gives us minus 4 over 2 or minus 2. So this is the axis, right, at minus 2. Now maximum value from the axis also gives you the amplitude. So you could actually read from the graph this much distance is actually equals to absolute value of amplitude. So you could measure even the minimum, right? That is the amplitude. So A in our case is from minus 2 you are going down to minus 5, so it is minus 3. So it is also represented by the distance, how far you go from the axis. Is it okay? If you do 1 minus minus 5 divided by 2, you get the same thing. And absolute value is all, so we are always taking absolute value. So if you do this kind of minus 3, you have to make it absolute. That's why we wrote absolute value and should be always treated as positive. Correct? So amplitude is 3. Okay. Now what? Phase shift. Phase shift for us is, well, in this case, we are considering the cosine function, and the maximum starts from pi by 4, so phase shift is pi by 4, or 45 degrees. The value for k is 2 pi by the time period, which is pi, so k is 2 for us. Now, based on all this, we can write down our function f of x as equal to amplitude of 3 cos of k values 2 x minus, since it moves right, pi by 4, and it has gone down by 2 units, so minus 2, correct? Now here also you could write equivalent sine function to represent the same. In sine function there is no phase shift, do you see that? So if you are writing sine function, it could be written as 3 sine, same thing. Everything else remains same, right? Nothing changes. The only thing is sine function, it starts from the axis itself, so there is no phase shift. So it's much simpler in this particular case to write sine function. Okay, so here is the last one for us, where I've changed a bit. I'm using sine function this time, not cosine. We've taken cosine most of the cases. Now here's a wave. We are given 2 points. One is A on the axis. So this is the axis. A is 6 minus 1. And the minimum is at 3 minus 5. I'd like you to treat this as your test question and write down your equation. So also write down the equation in the form of A cos kx minus p plus q. Okay. So let's do the same what we had been doing. But in this case, you're not given the maximum. What you are given is excess. So from this particular graph, we know the value of q is minus 1. Q is minus 1. And that we can read from the given value here. So what we are given, the point A is on the axis, correct? Now, how do you find amplitude here? Amplitude A, as I was saying, is distance from axis to maximum or minimum. So the distance is from minus 1 to minus 5, correct? So we could say absolute value of A is this distance. Sometimes you can get negative value, you have to make it positive. So it is, you could write minus 5 and take away minus 1, and that is, this becomes plus 1, so minus 5 plus 1, which is minus 4. So you have to take absolute value of this. This is important, right? Always A is absolute. So what we get here is that the value of A is 4 units. So that means you're going 4 units up and 4 units down from the axis, correct? Now let's look into time period, T. Now here you will see that I have not given you a point on maximum and minimum, or 2 maximums or 2 minimums. I have given you a point on the axis. Now if you see, the cycle which I am showing you is 3/4 of a cycle. So this cycle is not complete cycle. It is 3/4 of the cycle. The cycle completes right there. Do you see that? That is one cycle. So how much is this cycle? It is 3/4 of a cycle. So we can say 3/4 of our time period is difference between the x values, which is 6 minus 3 or 3. So the time period is 3 times 4 over 3, which is 4. So 4 units is the time period. Do you get the idea? So this is a very important criteria which you should consider. You may not be given points always on maximums and minimums. Sometimes you could have a point like this. correct? So the time period is 4, and from here we can get the value of k as, if you do it in degrees, 360 degrees divided by 4, or let me write or 2 pi by 4. Is it okay? Either way. So one of these would be the right way for you, depending on what units you choose. So if you're doing in degrees, it is like 90 degrees, and here it is pi by 2. Both are same things. Now, let's look into phase shift for a sine function. Sine function starts from here. So if the time period is 4, that is to say, we are going from 3 to 3. That means quarter of 4 is 1, so it is coming down by 1 unit. So this point here is actually at 4 minus 1. So you can say that the phase shift is 4, since this point is at 4. However, 4 is also the time period. That means one wave before here, that point should be 0 minus 1. Do you see that? So strictly speaking, our x-axis and y-axis, I could actually draw here my y-axis. Correct? My y-axis. So x-axis will be somewhere there. So now you can see that there is no phase shift. You could write 4 as your phase shift, but 4 is the time period. So strictly speaking, phase shift P is 0. So what we figured out here is that P is equal to 0. Since 4 is the time period, correct? That way, even after 4, it is going to start from here. Now we can write down our equation. So equation will be f of x is equal to, or y equals to, the amplitude in this case is 4 units. We are doing sine function this time. Sine k, if I'm doing in radians, it is pi by 2. X, since p is 4 and 4 is the time period, we are keeping it 0, right? Plus q, and the value for q is minus 1. So we'll write minus 1. It does make sense to you, right? Now if you use cosine function, then the phase shift is 1 unit. So for cosine function, I'll write f of x equals to 4 cos. Let me write this in degrees, 90 degrees. I mean, k will be 90. 360 divided by 4. And x, we have moved here by quarter of the cycle, right? Which is time period of 4, quarter is 1. And it goes up by, rather down by minus 1. So phase shift, if you write cosine function, is of 1 unit in this particular case, correct? So I hope with this you have learned and practiced how to write sine or cosine function for a sinusoidal wave. We have also learned that if maximum minimum are not given to us, we could still find the time period and the amplitude. Amplitude is difference between maximum or minimum from the axis. How far away are you from axis? And time period, sometimes we use half the wave, sometimes we use full wave. In this case, we use 3/4 of a wave to calculate the time period. I hope you find it interesting and useful. Feel free to share your comments and your views. If you like and subscribe, that'll be great. Thank you and all the best.